Hi everyone, I am Nur Farah Adina, net matrix number S70758, and today we are going to dive into a fascinating solution to climate change, which are ocean ion fertilization, or in short, OIF. What is ion fertilization? In certain parts of the ocean, there are zones called high nutrient, low chlorophyll zone, where there's plenty of nutrient except one critical ingredient, which is iron. Phytoplankton struggle to grow due to a lack of iron, a vital nutrient. It's like having a garden with soil, sunlight, and water, but no fertilizers. Without iron, phytoplankton can't thrive. So scientists come up with an idea. What if we add iron to these waters and fertilize the ocean? It's an effective method for stimulating oceanic carbon sequestration through the biological pump in iron-limited, high-nutrient, low chlorophyll region. By adding iron, we stimulate phytoplankton blooms, which absorb carbon dioxide from the atmosphere. This is part of what we call the biological pump, a natural system that helps transfer carbon to the deep ocean. What about atmospheric gas in ancient time? The idea comes from oceanographer John Martin back to the 1980s, who famously said, "Give me half a tanker of iron and I'll give you an ice age." His theory was inspired by ice core data showing that during the last glacial maximum, carbon dioxide levels were much lower, about 180 ppm compared to 280 ppm in pre-industrial time. How did Martin come to this finding? Dust inputs are generally regarded as a major natural iron source for ocean fertilization. Martin hypothesized that increased dust input, which is rich in iron during this cold period, relieved iron limitation in HNLC region, hence increased biological pump, boosted phytoplankton growth and drawing down atmospheric carbon dioxide. What are the main objectives of OIF? The main objective is to reduce atmospheric carbon dioxide by the enhancement of biological carbon dioxide uptake, stimulating phytoplankton growth through addition of nutrient. Where does OIF work best? OIF work best in high nutrient low chlorophyll zone, including the Southern Ocean, the subarctic North Pacific, and the equatorial Pacific. Also, area of iron fertilization include low nutrient and low chlorophyll region, which are subtropical North Atlantic. Okay, now what's interesting about this area? These are natural iron desert, high nutrient, low chlorophyll zone that are iron stuff but rich in other nutrients, perfect for testing OIF. According to the Martin 1990, Sermiato and Orr 1991, Cooper et al. 1996, and Marshall and Spear 2012, the Southern Ocean plays an important role in intermediate and deep water formation and has the greatest potential of any of the major ocean basins for carbon sequestration associated with artificial iron addition. The Southern Ocean in particular has enormous potential for deep sea carbon sequestration. How iron influence climate? Here's how it plays out. Based on the document, it indicates that during the last glacial maximum, increased dust input, a source of iron, will increase biological pump. Thus, will enhance phytoplankton bloom. Phytoplankton will absorb carbon dioxide, eventually die and sink. Carbon then is stored deep in the ocean. Additionally, will decrease atmospheric carbon dioxide level. This suggests that high iron availability can lead to reduced atmospheric carbon dioxide. Conversely, regions with iron limitation like Asian LC region have lower phytoplankton productivity and consequently a reduced drawdown of atmospheric carbon dioxide. Now, let's move on to the OIF experiment. How many experiments have been performed so far to study OIF in the field? To test this, scientists have run about 19 OIF experiments with 6 natural and 30 artificial. These were done in places like the Southern Ocean, Equatorial Pacific, North Atlantic, and Subarctic North Pacific. But here's the twist. Only a few light effects showed significant carbon export below the winter mix layer. That's where carbon needs to go for true, lasting sequestration. Most of them showed increased plankton growth, but only one, the effect experiment in the Southern Ocean, recorded significant deep carbon export. So the result promising but not yet consistent. But wait, what's the catch? What's holding OIF back? Potential limitations include short residence time of ion in water, where ion doesn't stick around, it disperses quickly. Next is zooplankton grazing, the phytoplankton before they sink. Lastly, light limitation, where there's no enough light or co-limiting nutrient like zinc and silicate can stunt growth. All these factors limit the carbon sequestration potential of OIF. So is OIF a climate fix? Not quite, not yet. While OIF boosts plankton and temporarily reduces atmospheric carbon dioxide, the long-term carbon storage part is still uncertain. That's why most scientists agree OIF is not a silver bullet for climate change. In simple words, artificial OIF still cannot be considered as a useful and successful geoengineering approach for the long run, but it's worth studying more. Now we come to the last part where it is the potential future for OIF. How we could do to improve experiment in the future. Future experiment like the Korean iron fertilization experiment in the Southern Ocean, key phase, aim to improve this. By how? By conducting larger scales over 10 times larger and longer term studies experiment. We multi-seasonal rather than typical 1 month studies. Next, by core measurement to identify key factors, monitoring not just carbon dioxide uptake, but carbon sinks and stay below the surface. Next, attention must also be given to the ecological and environmental consequences of ion addition, necessitating a combination of remote sensing, in situ observation, and modeling. Also, use high-tech tools like combining satellite models and on-site observation. Lastly, by collaboration, where we collaborate with social scientists to address ethical and governance issues to ensure that they are deployed with community engagement and in an equitable, just, and ethical manner with the appropriate social safeguard. Only by understanding the full picture can we responsible explore OIF potential. It's about doing better, smarter, and more responsible. In conclusion, so is ocean iron fertilization our ticket to saving the climate? Not yet, but it's a fascinating idea that could, with the right research and precautions, become parts of the solution. Just think, tiny plankton, invisible to the eye, with the power to shape Earth's future. Thank you so much for watching and keep asking questions because science always starts with curiosity. See you next time.